Okay, in order to prep data for a raster model where you're going to be adding different raster surfaces together, you need to kind of prep the data and keep a couple things in mind. Most importantly, you want to make sure that your cell sizes are the same and that the cells of the raster are lined up with one another. And you can do that in the environment settings of the tool. So what I've got here is a set of 3 raster surfaces. One of them is a rasterized stream layer where I've got a binary output of stream, not stream. Then I've got an existing vegetation type and a DEM. Now these are all 30 meter already, so I've already got that part taken care of. But what I want to show you is how you can make all these data sets line up perfectly. Okay, so the other thing you want to make sure, I think, is just good practice, is to make sure everything's in the same coordinate system. This DEM came in from the USGS. It comes in a geographic coordinate system, so I definitely want to make sure I project that one. And the landfire data comes in the North American Datum 1983 Albers. So it's projected, but not for my area of interest. And so just for good practice, I want to reproject these to make sure that everything's in UTM zone 13, which is correct for my area of interest here. So what we're going to do is, run project raster. Oh my goodness. Oh, for goodness sakes. All right. So project raster, and I can take care of all of this at the same time. It's pretty slick. I'm going to use the streams raster as my base, basically, because it's already in the correct coordinate system. It's got 30 meter cell size, and it's my smallest data set, and my area of interest is within this raster. So I'm going to go ahead and kind of clip everything down. So first, let's work with the DEM. I'm going to drop this here and just call it DEM. Put the resolution in there. Output coordinate system. I should be able to pull it from the streams, so that's correct. I don't need a transformation. Resampling technique. It's pre-filled for me. Can I just leave it? No. I am right now resampling basically a DEM, elevation data. This is continuous data. You have to change this to bilinear or cubic convolution. I haven't read up on majority resampling. This showed up literally today for me. So I'm going to stick with bilinear interpolation. I do have another video that talks through resampling techniques and why these are so important. Output cell size, I can have it match streams. It's going to set that to 30/30. Here's the money. In the environment setting, you have to go down to, close all these up, raster analysis. I'm going to cell size, I'm going to set it to streams. This is kind of duplicating, but I'm going to snap it to the streams. So when it does the resampling, it's going to make sure that the raster, the cells start and end at the exact same place. They're going to align with each other. Processing extent, I can also set it to streams so that it's going to go ahead and mask this bigger DEM, and I can turn this off, at the same time. Okay, let's see here. Just for kicks, I'm going to go ahead and stick that in there. All right, that's everything I know. I've got my processing extent set to streams, and I've got the snap raster set to streams. So I'm going to run it. I'm going to turn off the streams. And you'll see that it's created this new little DEM for me. Let me turn off the original one. So I've just got this little DEM now. If I go into the properties, it should have a coordinate system that matches the UTM. Okay, so that's been reprojected and it's overlaying correctly, so that's good news. Let's take care of the existing vegetation now. Same exact process except for the resampling technique. So I'm going to go back to this and put in my existing vegetation type. I'm going to call it, because I've already run this, Okay, output coordinate system, yes. For resampling technique, because this is land cover data, the values associated with the raster are categorical. Bilinear is going to average between neighboring cells. You can't average a value that represents one land cover type and another land cover type and get a median or an average value that represents some other magical in-between land cover type. So in this case, you have to leave it to the default nearest neighbor. Nearest neighbor means it's not going to do any kind of averaging between neighboring cells. It's just going to assign the nearest neighbor, so you don't get any funky made-up values in here. Output cell size, we're still going to match the streams, and then all this should have stayed the same. We're still processing just the streams, and we're snapping to the streams, so we're still using that as our base. And you can see that this is the existing one. If I turn that off, I've got this new guy, which is just about the same size as the streams and has been projected. Is ready to go. Now, why is it a little bit bigger? I don't know. I haven't looked into that yet. It should be the exact same size. It's possible that the processing extent, maybe it has something to do with the fact that it was in Albers before and the cells were a little bit tipped. This offset looks like it could be the same, but that's just me using funky intuition. So the idea now, though, is that we have 3 data sets that are concurrent and have matching cell sizes and are all in the exact same coordinate system.